video, let me introduce neural networks to you. So let us try to understand the building blocks of neural networks. Have you seen this diagram before? Yes, you must have seen in this high school, right? Yes, this is nothing but a structure of a neuron, right? You might have studied it in the nervous system. So let us try to understand why we are studying about neuron over here. So I said that we are going to study about the neural networks, right? So before that, we should try to understand the biological neuron, right? So here, the nervous system is made up of neuron. Each neuron is simple, and the human brain has 100 billion neurons with 100 trillion connections. The strength and nature of the connection stores memories and the program that makes us human. So a neural network is a web of artificial neurons. So let us try to study about the major components of neuron. So the first one is about dendrites. So the dendrites takes inputs from other neurons in form of an electrical impulse. The next one is about the cell body. It generates inferences from those inputs and decide what action to take. The next one is about axon terminal. It transmits outputs in form of electrical impulse. So in simple terms, each neuron takes input from numerous other neurons through these dendrites. Then it performs the required processing on this input and sends another pulse through the axon to the terminal nodes, from where it is transmitted to numerous other neurons. Now let us try to understand artificial neurons, because we are going to study about artificial neural network, right? So we should understand artificial neurons first. The artificial neurons is inspired by biological neurons. An artificial neuron is a connection point in an artificial neural network. So here, the neural networks are made up of artificial neurons, and neural networks are based on human brain, and artificial neurons are based on biological neurons. So this is almost similar to the biological neurons. So here you can see some input and some output, right? So here some processing is going on. So now let us compare biological neuron and artificial neuron. So in biological neuron, we have cell nucleus, and in artificial neuron, we have node. In biological neuron, it has dendrites, and here we have input. So whatever we study about input in artificial neuron, the same function is performed by dendrites in biological neuron. And its synapse. A synapse is there in biological neuron, where our interactions are present in artificial neuron. So whatever is being done by the output, the same thing is performed by the axon in the biological neuron. So let us understand what are neural networks. So neural networks are a series of algorithms that mimic the operations of a human brain to recognize relationships between vast amount of data. So why do we give more importance to neural networks? It is observed that comparatively to machine learning, this is giving a very good performance to the data. They are used in variety of applications in financial services, from forecasting and marketing research to fraud detection and risk assessment. So now let us understand what is perceptron. So perceptron is a neural network unit that does certain computations to detect features or business intelligence in the input data. So we will be looking into single layer and multi-layer perceptron. If you look into this, you can see an input layer and also an output layer. In this case, you can see an input layer and output layer, and in between input and output layer you can see some layers, right? So now I'm not going to tell you what are these layers. So this is called as multi-layer perceptron, which is called as MLP. Now let us try to understand the structure of a perceptron. Okay, so this is really important to understand. So now, when you have the basic knowledge of machine learning, this is going to be really easy to you. So now look into this. Like you can see x1, x2, x3, x4 up to xn. What are these basically? These are called as inputs. And you can see number one over here, that is nothing but a constant, right? And then you can see weights over here, which is represented as W0, W1, W2 up to Wn. Then you can see weight sum. So some summation is happening over here. And the next one, you can see an activation function. So let us understand it little more. In linear regression, we have studied about the expression y is equal to m1 x1 plus m2 x2 up to m1 xn plus c, right? So do you remember that? If you connect with this concept, this is going to be really easy. So what are the inputs here? X1, X2, X3 up to Xn will be the inputs. And there we will be studying about that. We have studied about slopes, right? So here it is called as weights, right? And weight sum in the sense like what is happening over here? W1, X1 plus W2, X2 up to Wn, Xn plus W0, which is nothing but the bias, right? So that summation is being carried out over here, and then we apply some activation function over here. So in input values, the perceptron takes real values as its inputs. Say for example, in case if we are trying to identify the iris flower, we may take some inputs like length of the petal or width of the petal, right? So those are called as inputs. So weights and bias. So weights represent the relative importance of each of the weights to the classification decision. So here, should we give more weightage to length of the petal or width of the petal, right? So that is basically weight. So a bias weight is added and multiplied by a constant equal to 1. Then the weighted sum. The input values are multiplied by the weights and summed up to create one aggregate value, which is then fed into the activation function. So the activation function generates a classification decision. Now, based on this, the iris is classified as setosa or versicolor, right? So hope it is clear to you, right? So let us discuss about the components of a neural network. So if you look into this, you can see input layers, hidden layers, output layers, weights, bias, and neurons. So what is input layer? So this is the initial data layer that is used to input our pieces of information, which is then passed on to hidden layers. So just look into this picture. So here just imagine that I am trying to find out the price of a house, and there I have some parameters like number of bedrooms, number of bathrooms, square feet of the house, and about the amenities. So whatever are the independent features that are basically called as input layer, right? So here this one is basically x1, x2, x3 up to xn. Hidden layer. Hidden layer is an artificial neural network in between input layers and output layers, where artificial neurons take in a set of weighted inputs and produce an output through an activation function. If you look into this, here only the complete process goes on, right? In the hidden layer, the complete process goes on. And the next one is about the out layer that will simply present the information that has been computed from the hidden layers. So the next one is bias. So bias is just like an intercept added in a linear equation. In a linear equation, we have studied y is equal to mx plus c, right? Y is equal to mx plus c. C is nothing but the intercept. So it is almost similar to the intercept. In neural network, we call it as bias, right? So moreover, the bias value allows you to shift the activation function to either right or left. So how do we calculate output? Output is equal to sum of weights into inputs plus bias. Say I have four inputs x1, x2, x3, x4 and four weights w1, w2, w3, w4. Now my output will be w1x1 plus w2x2 plus w3x3 plus w4x4 plus bias. So weight is the parameter within a neural network that transforms input data within the network's hidden layers. So when an input enters this node, it gets multiplied by a weight value and the resulting output is either observed by adding a bias to it. So let us consolidate all the points now, how artificial neural network works. Say we have three inputs. See, just for an example, I'm considering three inputs now, x1, x2, x3. Say the weights are w1, w2, w3. So what are inputs? These are the signals received by dendrites of the neuron. And these inputs are passed, right? So here the input processing happens. So the signals are processed inside the cell body. So what is happening over here? F is equal to W1 X1 plus W2 X2 plus W3 X3. So now the next step is that output processing and transmissions. So the processed output is converted into an output and transmitted through axon, right? So now the output signal received by dendrites of the next neuron. So there could be any type of output that particularly that is actually dependent on the activation function.